Hi, my name is Yasaini,
And I'm Thomas Matthew.
and here we're asking the question: Are piezo crystals practical vibration sensors?
So, with online school taking effect, many people are in need of microphones. And we thought to ourselves, hey, what if we could build our own microphone?
So, we were looking for random materials around our house, and we found a barbecue lighter, which happens to have these things called a piezo crystal, or piezoelectric crystal. And it has this effect to it called the piezoelectric effect. How fitting. So, it's typically made of like some sort of quartz, and it generates an electric charge that when a force is applied, whether that be someone's voice, you punch it. I don't know if you want to be violent to it. It's up to you. This was observed in 1880 by Pierre and Jacques Curie, and it's so unique because it's actually reversible, which I don't think is that common. I mean, hence why it's unique. Um, so that means it can hold an electric charge as well as produce an electric charge, and that's similar to how a microphone works, where it will almost form an electric charge from your voice in a sense. Um, and so piezo crystals are typically used for sound detection, frequency generation, microbalances. So,
So, we came up with the hypothesis that piezo crystals could be used as practical vibrational sensors, such as microphones.
and so here's part of our material list. So I want to just take a minute to explain a small amount of it, just so it makes a bit more sense. So the two diodes are meant to be used as they're meant to be used in parallel reverse series, which would help limit the voltage output to less than 5 volts. Hence why we don't fry our stuff. The index card is used as a diaphragm and a pop filter at the same time, which is nice. We used two capacitors because with one capacitor, not enough voice was coming out. So we used a second one, and it seemed to be working fine. Next, for the headphone cable, we actually, if you look here, there's a red and green wire here. This is called your left and right audio, and we had to solder these together while the ground wire here had to be separated, hence why we separated them using the diodes. Um, and then we just had to use an adapter, and the box was meant to isolate the microphone from any outside. Sorry, from any outside, uh, like like noise, for example, like environmental noise. Then we used the Sennheiser E835, which is this microphone that I'm talking into, and a preamplifier because when you would plug a piezo crystal into like a computer or some sort of audio recording source, it would um, actually put it at 0 volts. So we had to put it through a preamplifier to amplify it up to enough voltage so you could actually hear it.
All right, so the procedures consisted of taking the piezo crystal out of the barbecue lighter. That was basically just breaking the lighter and taking the crystal. Uh, Next, you have to split an audio cable into two ends and fray the wiring. Um, then with the frayed wiring, you want to twist the copper ends onto themselves for a better connection. Um, and next, you want to turn on your soldering iron uh, and start to solder two diodes together, facing opposite directions, of course, to limit the voltage coming through. Um, and then you want to solder a capacitor. No, first you want to solder the diodes onto the audio cable, and then a a, cap a capacitor or two onto one end of the soldered on diodes.
The left and right end.
Yeah. Uh, and then you want to insulate your connections with electrical tape, just so it looks a little cleaner, I guess, and you don't shock yourself or anything. Um, and next you want to secure the piezo crystal onto a large surface. We used a Girl Scout cookie box. This is basically just to increase the surface area that can pick up vibrations from a voice. Um, and then you want to plug the aux cable into an amplifier. And then from the amplifier, you want to plug the amplifier into a computer or something. And in our case, we use my computer just because it has an audio in, so we can record. Then you want to start your audio recording software and normalize the audio so that it all kind of matches up, so it's coherent data. And you want to compare the waves formed. See which one was closest to the original.
So this is what the piezoelectric microphone we made is, as you can tell. I look a little ridiculous talking into a Girl Scout cookie box with an index card taped onto it, but it works pretty well. And just for reference, this is what the contact microphone sounds like.
And here we'll look at our first file of data. So this was a keyboard spacebar noise where you hit this key, like the spacebar of the keyboard, and it's just three separate hits at increasing volumes. This was meant to get the plosive, like to figure out how well it picks up plosives, something like a p or t or s, like into a microphone. So the original data file we found had the sound waves of the top here. But then if you look at the piezo crystal, it actually picked up the plosives pretty well. The only thing it didn't do is pick up the fades too well. It picked up the last two fades, but it didn't pick up the first fade, which is that little ending part where it kind of fades into nothingness. The Sennheiser picked it up almost identically, which even though it is a high quality microphone, to pick up something like that coming from a speaker like that well is surprisingly like accurate. And the piezo contact, as you can see, just entirely picked up the plosive, but didn't really pick up much of the fade. And in fact, it's so noisy, meaning it's like zzz, like a buzzing noise. It's so noisy that you can actually barely even tell it fades out. It's just one big line straight up and down. If we look at the second file, which was birds chirping to show the effectiveness of detail over a very long stretch of audio, playing like basically right next to each other. So as we can see here, there's like a few minor big jumps and one huge jump right about towards the end, right before it fades out. So if we look at the piezo crystal, it picks up that jump like decently well, but you can tell as it's about to fade out, it picks up some sort of other jump that doesn't quite line up with the audio. We were trying to figure out what that is. I think it's just one of the birds, like it just picked up one of the birds chirping like extra loud, most likely because it's a higher pitch and it would pick that up easier. The Sennheiser again picked it up relatively accurately, almost identical again to the original, which is again very surprising, assuming it's coming from a speaker. But we're not totally dumbfounded. It is a very high quality microphone. And the piezo contact tried its best, we'll say. It's too noisy. Hence, then anything it picked up just flew up and down. Keep in mind, this is all recorded normalized to the same decibel range, meaning anything this thing picked up, it just started peaking outside of that decibel range, regardless if we tried to normalize it within that decimal range, which is just kind of expected. It is a contact microphone. It's meant for acoustic instruments. But that's why we thought it wouldn't actually be that bad for these tests, because it would be picking it up similar to how it'd be picking up an acoustic instrument. And the third data file is to show how accurate they are on mono files. Mono meaning like one like left or like it recorded in the left ear or right ear. The piezo crystal piezo crystal actually performed pretty badly this time around. It only picked up the plosive sections. It didn't pick out any of the fades, which here it's like the little squiggly lines in the audio. The Sennheiser picked up the fades pretty well again. Again, assuming it's coming from a speaker, very impressive regardless. And the piezo contact actually did almost a better job than the crystal here. It picked up the fact that it was fading, but part of it started to pick up as another plosive, causing it to have like a double like drum kick effect, where there isn't supposed to be a double one. It's supposed to be just one drum kick. The piezo crystal did a similar thing, but it's not nearly as like harmful to the ears, I guess to say. Like it's not nearly as invasive as the piezo contact.
So based off the data collected, it can be concluded that piezo crystals can be used as effective vibration sensors, and to add on to that, they can be used as effective microphones. The purchase contact microphone definitely did the worst in our data. And the piezo crystal did surprisingly well, keeping up with the Sennheiser. And we could also conclude that the piezo crystal might have done the same, if not better than the Sennheiser at picking up sound, if we would have constructed it a little bit better, as our construction is pretty rough, sitting in a Girl Scout box.
Yeah, if we maybe use like some sort of plastic container that would isolate it better from the outside noise, it likely would even perform better, which proves that we do have some room of improvement, but it does give a relative idea of what a piezo crystal would sound like when turned into a microphone. Thank you.